Professor Liu is going to show you how to do review 3, question number 1, to solve a second degree quadratic equation and to find the roots for this quadratic equation. First, we need to review what is a quadratic equation. We are going to do the second degree only, okay? So the quadratic equation of second degree, that will be y equal ax squared plus bx plus c. This is second degree. For this second degree quadratic equation, usually is a parabola, okay? It will be a parabola. And you will have two roots, sometimes one root only. If one root is exactly the same. So the root is when you touch to x-axis, okay? So for example, for this, x squared minus 2x minus 3, x plus 1, x minus 3. So that means your x here is 3. Okay, 3, x equal 3, this is 3, and x equal negative 1. So that means this parabola is going to intersect with x at 2 points, 3, x equal 3, and x equal negative 2. This is called x-intercept. Alright, so we need to learn more about quadratic. So actually a quadratic equation, okay, you must give me a, b, c. Both a, b, and c are integer, okay? Then there's an absolute rule is that a cannot be 0. A cannot be 0. And let's take a look some example right here. These are the example of quadratic equation. And this is also example of quadratic equation. For these samples, b is 0. Some of them c is 0. And these are the roots. So let's take a look. How do we solve ours right now? Okay. So we are going to do this first. We are going to have three big. I know they are integer, but because we are going to use SQRT, we are going to use SQRT, use POW. So we chose to declare this variable as double. So to solve a quadratic equation, you need to give me a, b, c. Once you give me a, b, c. So if this a, this is not a quadratic equation. Alright, otherwise I can solve right now. So I'm going to do the numerator first. So negative b plus square root of, so b squared minus 4ac. And this is a denominator. This is denominator. Alright, so we so root 1 and root 2. So we are so going to run this right now. So I build it. And I start without debugging. So if I give a 0, alright, and 4 and 6, it will tell me that it is not a quadratic equation. Okay, so I have to run with a number with a has a number here. So I'm going to use this example here. Okay, I'm going to use 1, negative 1, negative 6. Okay, and the answer should be negative 2 and 3. So let's do this right now. So 1 and negative 1 and negative 6. So the answer is 3. So let's take a look. So the answer will be 3 because x minus 3 is 3 and negative 2. Alright, so now we solve this problem for the first level. And I want to teach you a little bit more about this. The reason is we can use b squared minus 4ac as we call that discriminator. Okay, discriminant. The reason is if you're 4 squared minus 4ac, okay, So you will have if your minus 4ac, if you will have a real root. Otherwise, it has to be greater than 0. So greater than 0, you have x1, x2. Equal 0, you have only one root. Okay, the two roots are exactly equal. Less than 0, you know that you're going to have imaginary number. All right, so we are going to make this a little bit more like your pre-algebra or your high school math right now. So first, I'm going to get this right now. So if I get else once here, then I need to do this. So my discriminator. All right, so actually that will be equal b squared minus 4ac. Okay, so I'm going to say power of b to the second power. Okay, b squared. Okay, then minus 4 times a times c. All right, so first we do that. So I got this right now. So my discriminator I already got my discriminant right now. So I'm going to say this, okay? If my discriminant, if my discriminant, okay, greater than 0. All right, so if I'm greater than 0, I have two roots. I'm going to copy thing down. It's okay, right here. And put all the thing here right now. Control X. Alright, so if I have equal 0, then I have two roots. Okay, now I am going to do this right now. I am going to do if that's equal 0, if that's greater than 0, then we're going to have the other thing. Else if right now, okay, then discriminant equals 0. We're going to put equal 0. So if that's equal 0 right here, and we are going to the roots are real number, they are the same rule. Okay, so we are going to do this. Okay, so we're going to say this CL, hold on, let me do this. All right, so CL, we are going to say there is only one root. Okay, you're supposed to have only one root right now, and the roots right here will be negative b minus 2, negative b divided by 2a, because there's no discriminator anymore. So I'm going to say root 1 equal and negative b, okay, and divide by 2 times a. All right, so I'm going to just have like that one, and I'm going to say this. I'm going to say CL root 1 equal to root 2. Hold on, let me say like this. Both root 1 and the root 2 are, okay, both of them are the same, okay, and they are root 1. I'm just going to do like this right now, okay, and I'm going to say end of line. All right, so if my discriminator is this right now, and I got this, all right, so I am going to go to the one is else, the last one. I have a real and I have imaginary number. So right here, I need to add another one right now. I'm going to say real part. Imag, imaginary part. Okay, so I'm going to have that right now. So I define these two new variable. Once define new variable, I'm continue my if else statement. Okay, so else, that's my last part right now. Else, all right. So I going to do my real part. Okay, so my real part will be here. My real part will be equal to negative b divided by 2a. 2 times a. I have imaginary part. Okay, then I also have imaginary part, and that will be equal to sqrt, and that will be I'm going to use this. I already got discriminator, right? Did I calculate discriminator? All right, hold on. I did not calculate discriminator yet. Okay, this is called else. Oh, I did. So I'm going to say discriminate. Control C, and I'm going to take my discriminate. Okay, and this one I'm going to my discriminator and square root of that and divided by 2 times a, 2a, a. Okay, so now so I do like that. So I'm going to say this. Okay, so see how the roots are complex and different. Okay, so see how okay, so we're going to have a complex number as our rule, and so we say CL. All right, rule 1. Okay, let me copy these two lines. Okay, all right, rule 1, but I'm going to do this. Okay, I'm going to say this will be real part. All right, and real part, and I'm going to put plus sign space, plus sign space. All right, and imaginary part. All right, so don't forget your imaginary part needs plus I. Okay, all right, then end of line. Okay, so let me copy this thing right now from here. Control C, Control V. Now, but I'm going to change this to minus. Okay, and change this to minus. All right, so now let me double check. So I finished this one right now. So I finished this one. All right, so let's check this right now. Okay, so first of all, one more time, let's check the first one like we did it before. Okay, these are the one has real roots. Okay, let's do the second one right now. So 176 176. All right, so I'm going to build it and start without debugging. All right, so 1 7 and 6. So I got roots is -1 like here, -1 and -6. So we are okay right now. So we are right. But now let's check the one for the imaginary number. Okay. Okay. So that's coming back right now. Okay, I haven't to check the one has two roots. Okay. Same roots. So let me see right here. Let me double check right here. Just a minute. Just a minute. Let me see which one is one half that. Okay. All right. So let's check this right now. All right. So so let me check this one has only two roots. X squared minus 4. Okay. Let me try it right here. Okay. So build it, rebuild it, and start without debugging. All right, so let me check. This is 1, okay, x1, and 0 and -4, okay. So this one still have two roots, that's correct, okay. So I'm going to do this one right now. I'm going to check the one has a real part here, okay. Now check this real part. All right, so let me check the one has a discriminant is -0, okay. So will be a negative number. So let me do this right now. Let me do how about this, 4 and 5 and 1. All right, so I still have here, and let me see if anything has a imaginary number. Okay, so we're going to do another one is b squared minus 4ac -0. So we're going to do more example for that. Let me try the example. Okay, b squared minus 4ac equal -1. Okay, I'll find another example for you. All right, so this is your number review number.